Okay, so on section 2.4, page 184, now we're adding polynomials, which means we're adding things that are like. So when we multiply things like x times x, we're creating a new shape, a new unit. So we get like x squared. But when we're adding, we're just counting. So we don't get new shapes. So like 1 cat and 2 cats, I have 3 cats. I don't have cat squared, nothing like that. So in here, what I want you to do is I want you to go ahead and pause the video and then write what we're counting and then write what the sum would be. And if you can group it together, great. If you have to convert it to group it together, that's fine too. But think about what your unit is and then what your answer is. So I'm going to go ahead and pause it, go through this, and then we will chat. Okay, so in the first one, we're adding centimeters and meters. So we have 2 units. Fifths are our unit here because remember your denominator is your unit. So fifths. Hundredths, because they're in the hundredths place. Here we have what? Quarters and dimes. Here we have thirds and halves. And hours, minutes and minutes, and then hundredths, thousands, and 10,000. So when you add, you can add like things. So I get those are like, and we call those like terms. So I would get 9 centimeters and 8 meters, and then that would be my answer. Now, the only way I could add them is if I convert to a like unit. So if I had 9 centimeters and 800 centimeters, then I could have 809 centimeters. But again, you can't add things that are like unless you can convert them. Fifths and fifths are like. That's why we can add them and get 3 fifths. Hundredths and hundredths are like, so that's why we can get 8 hundredths. Now, quarters and quarters make more quarters, so 25 quarters. But there is no such thing as a quarter dime, so you have your dimes separate. Now, I could convert them all to money if I wanted to. So if I converted them all to money, I might get, what, $7 and I think 25 cents maybe. So again, if I want to convert them, I can. Then I can add them. Let's see, thirds and thirds I could add. So what is that? 7 thirds and a half. But if I want to add it more, again, your units would have to match. So I would have to scale this. So let's see, get a common denominator 6. So what, 14, 6, and times 3, and times 3, 3, 6. So 17, 6. I could leave that as an improper fraction. But again, if you're going to add, you need what we call like terms. Hours and hours, minutes and minutes. I'm going to go over here. So if I add those up, I could get hours with hours, 12 hours, and minutes with minute, I could get 56 minutes. Now again, if I want to add them, I could convert these 12 hours, multiplying by what? 60 to get minutes, and I could get 776 minutes. Or if I wanted to, I could be like, well, I want to divide this by 60 to convert it to hours, and I could get about 12.93 hours. So kind of, again, to add like terms, you need the same unit. And then the last one, we have a base 10 system, so I could line them all up, and I could get 0.0663. But again, otherwise I need to leave them separate, but I could put my hundredths with my hundredths, my thousands with thousands, and 10,000s with 10,000s, because that's how our decimal system works. All right, go ahead and look at the next page, page 85. Okay, so like terms in the middle here are things that are alike, things that we can add. So again, cats with cats make more cats, dogs and dogs make more dogs, but if you have cats and dogs, you can't create a new unit of cat dogs. So we just kind of put things in piles like they are. So if you look at the bottom of this page, and I don't know if I can scroll down, maybe not, I don't know. It's not wanting me to. There we go. So there is a video online if you want to watch it. But again, cats and cats, dogs and dogs. So I have 7x and a negative 3x because that negative goes with it. So I end up with 4 x's in my pile and y's and y's. So I have 2y, negative 4y. So I still owe 2y. So my final answer, if you flip the page, would be positive 4x and a negative 2y. All right, and they give you some directions here. So go ahead and try problem number 2, A, B, and C. R and C, you can use a calculator to do those fractions, so don't let those scare you. Just use a calculator. And then try D, E, and F. But again, cats and cats, dogs and dogs, you can go ahead and add those. So try collecting like terms and see how it goes. Okay, so let's look at this one here. I have a cat and I owe 9 cats, so negative 8a. Or I have an A and I owe 9 A's, I owe 8 A's. And then the 23 is a constant, so variables and constants can't mix. All right, so here I have squares with squares, so I have 16 squares and 8 squares, so I have 24x squareds. Let's see, x's and x's. Are these my only x's? So negative 12x. I don't have any other x's to put in that pile. And then if I look right here, y's and y's make more y's. Now, your knowledge from the other day is going to try to mess you up a little bit. So y's and y's, I just have 12 y's. I am not multiply them. So remember, when you multiply, you create a new unit, and things change. So I get 32y squared because I am multiplying these and creating this, you know, well, probably a two-dimensional object. That's a new shape. It's something new. Here I'm just counting. I have a y, a y, a y, and a y, 4 of them, and then I have 8 y's. And I'm not multiplying them, so I'm not creating a new shape. I'm just counting what I have. All right, so that is not going to change. If you put these in the other order like these, that doesn't matter. Usually we put the highest power first and work our way down. Now the next one might be bugging you because you're like, oh my gosh, we have fractions, but I'm not testing your ability on fraction here. I'm just testing your ability on collecting like terms. So my highest power, I have 17 y squareds and I owe a y squared. So if you have 17 cats and you lose a cat, you now have 16 cats, but then we have what? Something else. Where is it? Okay, there we go. Minus 3 halves w squared. So again, if you know that that's the same as 1.5, you could just subtract it yourself. Otherwise, you can use a calculator. So take, on your calculator, you could start at the beginning even. 17 minus 3 halves minus 1, enter on your calculator. And you should get 29 halves w squared, or that could be in decimal form. Okay, so you don't have to do this by hand if you don't want to. And if you have 14.5 w squared or 14.5 w squared, we don't usually do that because it's confusing as to what's the variable touching. So probably going to either leave it improper or a decimal like that. All right, then what about my w's? So you have a fourth, you owe a fourth, so that means there's what? 3/4 that's still missing. Again, think of money. If you have $1 and you owe a quarter, you would have 3/4 left. And again, if you're like, I don't know how to do that, use your calculator. So type in what? A negative, oops, sorry, I didn't mean to do that. Type in a -1 for that and a positive 1/4, add them together, and you'll get that -3/4. All right, and then the last thing is what? I just have a -1, so that's just going to go there. All right, try the top of the next page, and we'll see how it goes. Okay, again, apples with apples, x's with x's. Now, these are square roots, but again, that doesn't matter. You're just counting them. I have 3 square roots of x's, 5 square root of x's. I have 8 square root of x's. I'm not creating a new shape, just counting. Here I have 9 xy's and 17. Now, xy's would be a two-dimensional object, like an xy, but you're just adding them. How many of these xy things do I have? 9 and 17 gives me, what is that, 26 xy's. I owe $9, I have $8, so I owe $1. Right? And again, if I were multiplying these, it'd be a whole different story. So if I'd say 3 xy's and 6 xy's, when you multiply, you are creating a new object, like some little, you know, 2-dimensional, 3-dimensional, some weird shape. So 3 times 6 is 18, but notice you're creating something new. So powers would change in that case. But here we're just adding, we're just counting. All right, the next one is imaginary numbers, but don't worry about it. Numbers with numbers. Okay, so I have 3, I owe 7, I owe 4. I's with i's. So positive 4, -9, I owe 5 i's. And again, that's an imaginary number, but again, same idea. All right, so down here, try to add and multiply. Remember, when you multiply, you're creating something new. Things change, and you can mush it completely. See how I can mush it into one chunk? These, you can't always mush into one chunk. Okay, so try number 3. Again, when you know both, it kind of does mess with your understanding, so we're going to have to get good at this. All right, so try number 3. Okay, so which ones are going to mush completely and which ones are not, or which ones am I going to change shapes and which ones am I not? So when I multiply this one and this one, I am going to mush completely. I'm going to change shapes. So 4 times 4 is 16. Again, if in doubt, write it out. I have all these factors. I am multiplying, and I have, that's a 4, I have 6 of them. okay, because I'm counting, but I'm actually mushing them. I'm creating something new. This one I'm also mushing, so I get 16x to the 4th, because I have 4x, x times 4x. I'm creating a new shape. I'm multiplying. Now these, I'm just adding like terms. Cats and dogs, so 4 cats and 4 cats make more cats. So I have 8. Now what shape am I counting? I'm not creating a new shape. I'm just counting the thirds. And then here, I have cube shapes and other shapes, but notice they are not like terms, okay? So my answer, that's the best I can get. I can't mush it anymore, okay? Yeah, you might have like, oh, say someone's name is Julianne, and then you have a Julie. You can't say you have 2 Julies. Yes, they both have that as part of the name, but her name is Julianne, her name is Julie. You can't add those together. So even though you're like, but they both have x's, yeah, but they're not the same. This is x cubed, which is a 3-dimensional shape. This is just an x. Those don't look the same, even though they have the same part of their name. All right, okay, let's read the example 2 on the bottom here, and then we're going to turn to page 188 and chat about that quick. Okay, so try these quick. If you need to go back a few pages and look at the formulas, go ahead and do this. But again, try these on your own, see how you do. Okay, so let's look at this. So edging needed is perimeter. You're just putting edging around it. So I'm adding 76, and again, we want it on all sides. So 76 centimeters, another 76 centimeters across from it, and then the 46 on both of the sides. And if you put the units in here, you can kind of see what's going on. I'm just going to add all these. But notice, am I creating a new shape? No, I'm not counting squares inside there. I am just like putting string around the outside. So I'm staying in centimeters. So if you add those all up, your unit does not change. It stays centimeters because it's just like string. The string is not turning into something else. Now, if I was doing area, whole other ballgame. All right, now I looked back at my surface area formula. It's this. So they say leave pi in there till the end. All right, so we're going to take, what's the radius? So half of $2.50 is what, $1.25? And I'm going to put my units in there, which is what, inches, and that's squared, plus 2 pi, radius again is 1.25 inch, and my height is 6. And again, if your units don't match, then you need to get inches and inches, feet and feet, things like that. All right, so if I do my math here, I'm going to get an answer to that, and then I'm going to get an answer to that, and then I'm going to combine them. All right, so my first answer is what? 3.125. So if I square this guy, 1.25 squared, and multiply by 2, and then I still have the pi, but notice the inches get squared too, so my unit is square inches. And then now I have to take the 6 and that with my pi, so I end up getting about, what is that? Oh, that's going to be exactly 15 pi. And notice inches times inches give me square inches. So now I have the same units, so I can add these. And again, I'm going to add them like a pi, like 2x and 3x. I have 5x if I'm adding. So I'm going to go ahead and add those, and I get 18.125 pi. And then my label is square inches. So on my math lab, if they want the answer with pi, you just leave it. But we know that pi is, 3.14159, or use a pi key on your calculator. Those aren't forever. So you can multiply that times that, and you should get about 57. And again, unit square inches. Okay. So again, when you're doing perimeter, it's just like a string that goes around it. So it's not changing shapes. It's staying one-dimensional. And so do you see how my unit is one-dimensional? When I do area, I'm covering it. So say I have 2 inches and 4 inches. I'm covering it with squares. So I'm going from something that is one-dimensional and one-dimensional, but then when I multiply, I'm creating something new, a 2-dimensional object. So that's why like 2 inches times 4 inches is 8 square inches, because my inches and inches make square inches. And notice the exponent change because I'm creating this new object. Okay? All right, so try this section, see how it goes, and we'll go from there.